I prepared for y'all a little neuroscience history lesson.
Ooh,
Are
yeah.
you excited about that? All right, so what I want to talk to you about is some of my favorite historic brains from neuroscience history that have really taught us a lot about how like the human brain works in particular. So if you're ready, let's go. All right, so a really good place to start is like what makes the brain really special? And I want to tell you about kind of an interesting problem that I think neuroscientists face when they're trying to study their organ of choice. And it's not that it's only neuroscientists that face this problem, other biologists do too, but I think it's kind of uniquely hard for neuroscientists. And that is that when you look at the structure of the brain, it doesn't immediately like tie to the function of the brain in a way that's really obvious for other organs, right? And what I mean by that is if you look at an organ like the stomach or the heart that I have here, the stomach is a muscular bag with some like mucosa. It secretes acid. It holds onto food. It's got some valves that keep the food from moving before it should. And like if you look at it, it's a bag that holds food. Like that's what it does. Or the heart is a muscular pump. It's attached to a bunch of like valves and it's got some tubes and it pushes blood through the body. But when you think about the brain, like what the fuck does like what does that do? Like I don't know. So one of the things that neuroscientists kind of face is that like when we look at the organ, like we can't just say like, oh, that part does this or this part does this other thing. And so we're kind of relegated, well, not really relegated, but we have a unique opportunity to think about how behavior is shaped by the brain and how actually what happens when the brain gets kind of fucked up is a really nice way to learn about how the brain functions. And so that brings me to my first story for you, and that is the story of a man named Louis Victor Le Borgne. Le Borgne was a Parisian, he was also known as Monsieur Ten. So here's his brain in a jar in case you're into that sort of thing. I don't know what that meant. So Le Borgne,
Somewhere a podcast listener was like, oh, I wish I could see it.
it's a cool brain. Just Google, just do a Google. So Le Borgne was born in the early part of the 19th century, and he had a host of health problems throughout his entire life. From a very young age, he suffered from these bouts of epilepsy, but then later he actually developed like hemiplegia, which is like paralysis on one side of the body. He also, really interestingly, and I think this is like the reason that he's most famous, is he developed this condition called aphasia, which is a loss of the ability to express speech or understand speech, or sometimes both. So by the end of his life, he was actually he was only able to articulate this one word, "tan," and that's where he got his nickname, Monsieur Tan. If you need an example from like more contemporary stories of aphasia, then go to your childhood. I just kind of dated myself, but whatever. So anyway, by the end of his life, he was only able to say this one word, and his doctors thought like it must have something to do with his brain. That was where a lot of people were looking for these kinds of behavioral problems, and it turns out that when he died, they found this like huge ass hole in the side of his brain, kind of so this is the front, that's the back, in the front left side of his brain. They found this really big lesion. And they thought that this must explain what was going on, especially with his aphasia. So that's a really clear link between damage to the brain and behavior, but there's a problem with this story because we have no idea when that happened, right? So it's a little bit messy. So it would be better if we had a story where there was a clear beginning and end to, well, before and after, I should say. And I think I love y'all. Y'all are great. I love you. You're my girl. I'm loving this. I'm loving these reactions. It's great. So I think you know where I'm going with this. And that's the story of Phineas Gage, who is perhaps the most famous brain in the history of neuroscience. And so some of you are probably familiar with this story already. But Gage was a railroad foreman, and he was blasting away rock to make way for some new track that was being laid, actually up in Vermont. And he was the victim of this really grisly accident in which this iron tamping rod that you see right in his hand there was driven by an explosion up through his jaw, behind his eye, through his brain and then out the other side. It actually landed like 80 meters away.
So, Devon, I have a question about like accounts of the incident.
Yeah.
Do you know that when the tamping iron, when it came out of that gauge, was it doing just fine? Thank you.
And that, folks, is how
That's
it's
all.
done.
I yield my time.
I'm just gonna like now the killers are just gonna be like in my mind. Wait, that's the killers, right?
Yeah, right.
Okay, good. I swear I'm a millennial. Okay, here we are. So that rod took a really interesting path through Gage's body, and it ended up destroying this part of his brain. This is actually this is obviously not his actual brain, but this is a predicted path based on the damage to his skull and firsthand accounts. So it ended up penetrating this part of his brain called the frontal lobe. And as many of you may already know, that's a really important part of the brain for like regulating a lot of the behaviors that we think are really important to our human social lives. And in fact, there are a lot of firsthand accounts of how Gage's behavior changed from before the accident and then after. And I'll just read for you here. We have been informed by the best authority that after the man recovered, and while recovering, he was gross, profane, coarse, and vulgar to such a degree that his society was intolerable to decent people. Before the injury, he was quiet and respectful. So there's this a really profound change. And actually, a lot of these accounts of Gage's behavior may be a little sensationalized, but the effects are really clear. He had this big behavioral change after damage to his brain. And so that really highlights, damage to the brain can reveal a lot about how it works. But this is still a little bit troublesome because that was a very, and I'm sorry, messy example of how damage to the brain can change behavior. So we need something a little bit cleaner. And that brings me to one of the more recent stories that I want to share with you. And this is the story of a man named Henry Mollison, whose childhood problems with epilepsy ended up revealing a lot about how the brain makes and stores memories. So the story for Mollison goes that at a young age, he had these very terrible epileptic seizures. And they seemed to be pretty intractable to a lot of the treatments of the day. Like medications didn't work, other treatments didn't work. But his doctors were able to find where his seizures were originating in his brain. And it ended up being this little seahorse-shaped band of tissue on either side of the brain called the hippocampus. And the hippocampus, as you probably know, is really important in memory. But we didn't know that until after Mollison's story. And so his doctors were like, fuck it, we'll just take it out. It's causing the seizures, let's get rid of it. And so you can see, it's wild. They lifted the rest of his brain out of the way and then went in with suction and cauterization and just ablated his entire hippocampus.
Wow.
And it was kind of a success. So there you go, hippocampus missing. His epilepsy improved. He had fewer seizures. They were less intense. But something really crazy happened. He couldn't form new memories after that. He was essentially left with only the memories of what happened maybe years before his procedure. And he would meet his he would be like he was meeting his doctors for the first time every time they came into the room. He could only recall things that had happened maybe 10 years before the procedure. He could have conversations. He was completely normal in lots of other ways, but if he looked away, he would forget what he was talking about. And so this attracted the attention of a few different researchers, but I want to highlight here because it's Women's History Month. This woman here, pioneer of neuropsychology, Brenda Milner, who worked with Mollison for most of the latter half of his life. And she's actually still alive today. She was born in 1918. She's 105 or 106 years old.
God.
She's fucking kill it. Neuroscience makes you live longer. So Milner had Mollison do a few different things to test how he could form new memories and do other tasks. One of them was this really interesting tracing task in which he had to trace the inside of that star, but he could only see what he was doing through a mirror. And as you could imagine, it's pretty hard. So every time he touched the line went out of the line or like had to pick up his pencil and start a new line, that was counted as an error, and they would count the errors in every trial. And something really magical happened. They had him do this a few times, and he couldn't remember ever doing it or being exposed to it, but over time, he would get better at tracing the star. And that's really wild, because what that shows us is that memory is in more places than just the hippocampus. So even though he couldn't remember the who, what, when, where, why kinds of memories, he had what we call, like, more colloquially, muscle memory, right? And we know that that exists in other places like the cerebellum, and other kinds of memories like long-term memories are distributed around other places, like generally in the cortex. And that's really cool, right? And I've got one more story for you. Can I tell you one more?
Yeah.
Please do.
All right, so this one is maybe one that you haven't heard of unless you're a hardcore neuroscience history buff.
So for just a second with the lights, I thought that was M's shadow behind us.
I did too, and had to stop myself from being like, we're good.
So I'm glad you said that, because there's actually a reason that we have a silhouette, right? So Henry Mollison died in 2008. And before he passed away, he was only known as patient HM. But SM is still alive. She's actually a woman she's about like in her 50s or 60s at this point. And so to protect her privacy, we only know her by these initials. But she's better known as the woman with no fear. And that's because she has a rare genetic disease that ended up destroying these two little almond-shaped pieces of tissue in her temporal lobes. Actually, they are right next to where the hippocampus is, right at the ends. And you can see here's a brain scan. We're in the 20th and 21st century now. So here's a brain scan from a healthy brain, and here's SM's brain. And those little black dots, or those little black spaces right there, are where her amygdala should be. And this happened to her when she was maybe in her teens, early 20s, and her behavior also changed very profoundly, and she was basically incapable of feeling fear that other people would feel. So researchers took her to like an exotic, oh, sorry if you're afraid of snakes.
But our audience, totally fine.
Amygdala's all around.
Yeah, your amygdalas are in good shape. So they took her to an exotic pet store to try to like have her handle a bunch of like tarantulas and shit and snakes. And she said that she's afraid of snakes. Like, so she'll by self-report say, I don't like snakes, I'm afraid of snakes. But she was like holding it to her face and like touching its tongue and like had no problem. They took her to a haunted house, like one of the most like haunted houses in like, I don't know the region, but like maybe the country. And she actually freaked out the people who worked at the haunted house, because she was like just stone-faced, like didn't give a shit, like didn't care. And then it also got her into trouble. Like on her way to work, she would frequently take like a path through this, or way home from work at night. She would take this like path through a vacant lot, and she actually got mugged at like knife point at least once. But she, at least at the time that I heard the story, was like still taking that same route back. And like anyone with intact amygdala would probably avoid that after being mugged. So she essentially felt no fear to like external stimuli, but that wasn't all. She also wasn't able to identify signs of fear in other people. And so if you showed her an array of like, these are some of those, like you've heard of like the basic emotions, right? Plus neutral face. If you had her appraise what emotions were here, she would be able to identify all but this fearful face right here. And so that was really interesting, right? She doesn't have these like fear responses that people normally have, but she also can't detect fear in other people. So what's going on there? So some researchers decided to look at that. So what they did was they had her look at a few computer-generated faces, and they tracked her eye movements to see what she was looking at, and also to see like, does she have some sort of visual impairment that was causing this phenotype. And what they found is that healthy controls would spend a lot of time looking at the eyes, but SM is kind of looking nowhere in particular. And it's a little bit easier to see on this heat map here. When people are just kind of like looking at the picture, they look at the eyes. SM is looking, I guess, kind of at the nose, which is like a very expressive part of the face, I guess.
What if she likes noses? Did they control
She
for
might just
that?
like noses. They should have built in that control.
He's like,
Do you think
I'm not afraid of this, but that's a nice nose right there.
do you think nose fetishists also have bad fear conditioning?
Yo, all right, I'm gonna
Am I
start.
spoiling something? Really?
No, that's not coming up. And so, what was I saying about this? So, SM is only looking at these parts of the face. So, but what's really interesting is that if you instructed her to look at the eyes, she's not looking at the eyes, just baseline, whatever she wants, she can't identify fear. But if you tell her, hey, look at the eyes on this picture, she's able to perform the task just as well as controls. So it's not gone, right? Her ability to detect fear is not gone, and it's about the attention that she's paying to the information that she's getting. All right, and I'm almost done. So that was really cool, but they wanted to see, like, okay, is her fear completely gone? And there are lots of different things that can make you fearful, threats from outside, but also threats from inside. And in M's honor, I had to say something about the lungs, so there are your lungs.
Look at the girls.
I'm making peace here.
I do appreciate the stop! That's how I felt when I found out that we were hosting another brain show.
All right, if I could delete the picture of those lungs, I would do it.
No!
So the next experiment that I want to tell you about is, I don't know if it's a different set of researchers, whatever. They fitted her with a mask and pumped CO2 into the mask at sort of increasing concentrations. And what that would do in pretty much anyone, any human, probably most organisms that breathe, is it causes this really important and really strong autonomic response. You feel like you're choking. It's like apnea or asphyxiation. And so what happened with SM and a few other people who had similar lesions, so you can see no amygdala, amygdala gone. They rated it a really, really aversive experience, and they started to show the symptoms of a panic attack. But that wasn't all. I fucking love this story. They actually had higher ratings of panic than the control. So everybody was panicking, but the people without their amygdala were panicking a little bit more, which shows that not only is the amygdala like important for sensing fear and evaluating fear, it might also be controlling panic in really tough, challenging times. So I think that's the end of the story, is it?
That's so cool.
Yeah, that's all I got. Okay, so one more slide for y'all. We have a lot of different ways of looking at the brain, not just brain damage, is how we find things out. And I gave you a lot of information here. And what I'd like to leave you with is that if that broke your brain, please give it to me because I would love to study.